Okay, this is the final review of Chapter 2, Ratio, Rate, and Proportional Reasoning. This is your May-June review. The first questions are true and false. It says, if there are 5 red marbles and 10 blue marbles, the ratio of red to blue marbles is 5 to 10, or 5 to 10, or 50%. Well, the answer we know is false. And the reason why is you cannot use a part-to-part ratio to make percentages. If you wanted to say what percentage are blue, it would have to be 5 to 15, meaning part, which is your red marbles, to all, which is 15 marbles in total. Or you can go 10 to 15. So this would be 1/3 of them are red, or 33.3%. And then 2/3 would be blue, which would be 66.6 repeating percent. So the answer is definitely false. Question 2. A rate compares two, this is spelled incorrectly, I think a TWO, two quantities measured in different units. Is that true? Well, a rate and a ratio are a little bit different. The only difference is rates measure different units, like distance to time, dollars to donuts, those types of things are what we would measure in rates. And a unit rate would be even more specific because the second term would be 1. And our third question says, if a large coffee is $2.40 for 400 milliliters, this is a better deal than $2 for a 340 milliliter medium coffee. For these questions, what we really want to do, and what work you would want to show, is you'd want to break it down into a unit rate. So we've already declared that the easiest unit rate to use for things like liquid, 1 milliliter, back up. So this is actually 1. This is 1 deciliter, but we call it 100 milliliters because it's easier. And when we divide both by 4, we find out that it's, what would that be? 120, that'd be 60 cents for 100 milliliters of the large. And the medium would be, if I set it up as a ratio, $2 for, oh, I got that backwards. No, I don't. For 340, or sorry, 340, that's not a decimal there, milliliters. Divide by 3.4. Divide by 3.4. But instead of doing divide by 3.4, I'm going to use a different method here, actually. I'm going to set it up using the algebraic method. So if I say it's $2 for 340, how much is it for 100 mils? I can multiply across here to get 340x equals, multiplying $2 by 100 would be 200. I can then divide both sides by 340. And when I do so, x would equal whatever 200 divided by 340 is 0.59 approximately. So therefore the medium is a slightly better deal, but it says the largest, so therefore your answer has to be false because your medium is fractionally smaller per 100 mils. Question 4, true or false? A car traveling at a constant rate of 100 kilometers an hour can travel 60 kilometers in under 35 minutes. So we're going to put 100 kilometers in 1 hour. How long will it take to go 60 kilometers? So what I'm going to do here is I'm going to set up my proportion like this. I know that 100 kilometers in 1 hour, how long will it take me, x, to travel 60 kilometers? The algebraic method is probably the easiest way to work it here. So if I multiply across my variable side, I get 100x. If I multiply the other way, I get 60. Actually, you know what I'm going to do? I'm going to change that 1 hour. Since I know it's going to be in minutes, I'm going to change that 1 hour to 60 minutes to start, because I know my answer is going to be in minutes and I don't want decimals. So I'm going to get 100x here. It's still an hour if it's 60 minutes. I'm going to get 3,600. And when I divide both sides by 100, I can actually just knock off those zeros there. I get x equals 36. So therefore, it would take 36 minutes to travel 60 kilometers, which is not under 35 minutes. It's over 35 minutes, so therefore, it is false. It takes 36 minutes to travel 60 kilometers. Question 5 is an example of a unit rate because 100 grams is really a decagram, but we don't write decagrams because it would confuse the heck out of people who are already shaky with the metric system. So we call it 100 grams, and it is a unit rate. Question 6, this particular example is a poor one because it actually is not even possible. I think I said change this to, I think I said $10.67, I think. That would be the proper number. And this is an example of a proportion, right? If it's 60 cans for $12.80, that's a rate. That's proportional to 50 cans for $10.67 approximately, which is a proportional reasoning, so the answer is true. Which is a better deal? Again, we have the same question as before, so I'm gonna press pause here, and I'm gonna do all the work and show you which one the better deal is. So therefore, when you work out all the details, you find out that the cheapest price is the unit rate for the large, which means large is your best deal. Question 8 says, Donnie can travel 2.5 kilometers in 5 hours. Danny can travel 3 kilometers in 360 minutes. Who traveled the fastest rate of speed? So the first thing you probably want to do is break them down so that they're not in hours and minutes, but they're all in constant units. I like changing hours to minutes, so I'm going to put Donnie, and I say he went 2.5 kilometers in 300 minutes. And Danny went 3 kilometers in 360 minutes. So if I break this down into a unit rate per minute, I suppose we can do per minute. Doesn't matter. We'll just divide by 300. Why not? It's going to be a small number. If we do that, actually, it would probably be easier if I did hours in hindsight, but whatever. We're okay. 2.5 kilometers divided by 300 minutes means he was going 0.008 and a third kilometers every minute. And if we look at the other one, 3 divided by 360, he was going 0.008 and a third every minute, which means C, they were both the same. Question 9. It says, if a recipe for cookies calls for the ratio of eggs, which is, somebody said, how do you have half an egg? Nathan was very deep, and yeah, very smart people in this classroom. We'll pretend they're hard-boiled eggs when you're making cookies. That would be really gross. How many cups of flour would you use for 4 eggs? So 1.5 to 2 is the ratio of eggs to flours. If I have 4 eggs, how many cups of flour do I need? 1.5x will equal 8 when you multiply across. Divide both by 1.5. And 8 divided by 1.5 is 5 1/3. So x will equal 5.3 repeating eggs, or a better way to write it is 5 1/3 of an egg. I think the harder question is not can you have half an egg, but how can you have a third of an egg? That's the harder part. Sorry, my fault. That's 5 1/3 cups of flour. Okay, question 10. If Joe can run 320 steps in 8 minutes, how many steps can he take in 9 minutes? This is simply a really easy proportion. How many steps in 9 minutes? So let's do it a different way this time. Let's take this 320 in 8 and figure out how far he went in 1 minute instead. This one I can do with division rather than algebra. This would be 40 steps in 1 minute. And if I want to get back up to 9, I now know he took 360 steps in 9 minutes because he takes 40 steps a minute. 360 steps. Question 11, if donuts cost $8.40 a dozen, how much is one donut? So really, I'm just asking if you know what a dozen is. That's 12. How much is it for one? Believe it or not, there still are students who don't know what a dozen is. All right. So $8.40 divided by the 12 donuts means the cost of a donut is 70 cents. If they put 0.7 and didn't define it as being $0.7, just circle it to make sure they understand that on the exam. They better be very careful with units, right? Question 12. A sprinter can run 100 meters in 12 seconds. At this constant rate of speed, if he was not slowing down at all, but able to maintain a constant rate of speed, how long would it take him to run 1.5 kilometers in minutes? So, 100 meters in 12 seconds is, we'll go 1.5 kilometers, which is 1,500 meters, and I don't know how long. So here we know we multiplied it by 15. So if I multiply 12 seconds by 15, I know it's going to be 180 seconds. Since there are 60 seconds in a minute, if I take that 180 seconds, or seconds in a minute, and divide it by 60, it will tell me that 180 seconds is also known as 3 minutes, which is your answer. So the answer to that question is, how many minutes will it take? It'll take 3 minutes. Question 13, using proportional reasoning, if a penguin can eat 20 fish an hour, approximately how many fish can they eat every 36 minutes? So the first thing I'm going to do is I want to set up my proportion. I'm going to put it fish to time. I want to make sure I keep this fish on the top, time on the bottom. So 20 fish in 60 minutes. Now notice I changed my hours to minutes because in the second one I have 36 minutes, which is my time, but I don't know how many fish. Very important that you keep them in minutes and minutes and not 1 and 36, because it won't work if you do it the other way. I'm going to solve this with algebra. 60x is equal to 720. Divide both sides by 60. X will equal 12. And therefore, the penguin could eat 12 fish in 36 minutes. Question 14, a shadow is proportional to an object in the same location at the time of day. This is the one we went outside and did. If a shadow of a 12-meter tree is 5 meters long, so the first thing I'm going to keep my words here. On your exam, it's probably best that you keep things organized for what you want your number on the top to be and what you want your number on the bottom to be. So here I have two numbers. 12 meters is the object's height, so I'm going to put that in the top one. And the 12-meter tree has a 5-meter shadow. And the teacher's shadow is one. How long would a 1.87-meter teacher's shadow be? So here I know how big the teacher is, which actually happens to be my height. Right? And I don't know the length of the shadow, because that's what it's asking me. How long would the shadow be? So here, again, algebra is the easiest way to tackle this sucker. If I take my 1.87 and multiply it by 5, I get this really weird looking equation. Divide both sides by 12. And x will equal, wow, 0.779. So we're going to make it roughly 78 meters, or, so 0.78 meters, or a better answer would be 78 centimeters. But both answers are the same. Roughly. Something around that would be good. And one of your last ones here. This one doesn't require a whole lot. You just have to know how many months are in a year. So if you multiply this by 12, you get a year. So therefore, if you divided this by 12, you'd get a month. And if I divide this by 12, I would get $2.05. So therefore, it's $2.05 a month. The next question is 120 beats in 1 minute and 40 seconds. How many in 2 minutes? First thing you want to do is break it down into either a minute or a second. I'm going to go down to second. So if 1 minute and 40 seconds is actually 100 seconds. So this is the exact same thing. I just changed 1 minute and 40 seconds into just seconds. Divided by 100. I'd have 1.2 beats per second. And I'd multiply that by 120, because that's how many seconds are in 2 minutes. And if I take my calculator Okay, 1.2 beats multiplied by the 120 seconds would mean there's 144 beats in 2 minutes. Question 17, if you were to buy U.S. money at the bank, $100 Canadian would get you approximately 73.25. So I'm going to put Canada on the top, which is where we should be in the world, and the USD on the bottom. $100 Canadian will be 73.25 in US. And if I give you $100 US, how much Canadian would I get? I could set up it as a proportion that way. Algebraically, I'd have 73.25x because I multiply this way first. 100 times 100 is 10,000. Divide by your coefficient to isolate. And the amount of Canadian you would need would be 10,000 divided by 73.25. The answer is you need about approximately 136.52 or 51.8, whatever. 136.50 something. Rounded to the nearest cent would be 52. Is that the last question? No, one more. And the last question, if water flowing from a tap flows at a rate of 800 milliliters in 1 minute, so 800 milliliters in 1 minute, how long for 1 day? How much milliliters in 1 day? Well, how many minutes are there in a day? Well, there's 24 hours, and each hour has 60 minutes. So if I multiply that out, I get 1,440 minutes in a day. Multiply this by 1440 and 1440. I get 800 multiplied by 1440. I get 1,152,000 milliliters, but it says express your answer in liters. Since there are 1,000 milliliters, I have to divide this by 1,000, and that will tell me the answer is 1,152 liters.